Alright, so this video is about how to draw free body diagrams. A free body diagram is a way to easily see all the forces that are pushing or pulling on a particular object at a particular time. They're useful, they're needed, so that we can figure out the total force on an object, or to figure out maybe the magnitude and direction of one particular force. But basically, anytime you use Newton's second law in a problem, you'll have to draw a free body diagram. Let's start with a simple example of just a coffee mug sitting motionless on a desk. So the first step is to just draw the very simple picture of the object that we're looking at. Representing the object with just a simple square or a circle is fine. Since we're analyzing the forces on the coffee mug, we draw only the coffee mug and not the desk it sits on or anything else. The next step is to identify all the forces acting on the object and their directions. Sometimes these will be given to you in the problem, and sometimes you'll need to figure them out for yourself. The mug has two forces acting on it. Gravity pulls downwards on the mug, while the normal force from the table pushes upwards on the mug. The third step is to draw a vector arrow representing each force. The vector should always start in the center of the object and point in the direction of the force. The stronger the force, the longer you should draw the arrow. Finally, we need to label each force with an appropriate symbol. Fg is what we usually use for gravity, and Fn is fine for the normal force. If you know the magnitude of the force, add that to the diagram too. I happen to know that my coffee mug weighs 1.5 newtons, so I'll add that to the diagram. And that's our complete free body diagram for our coffee mug on a desk. Let's try one more example. We have a certain airplane in flight that feels four forces. It's got a 1.0 meganewton, that's million newton, 1.0 meganewton force from gravity downwards, a 1.6 meganewton forward thrust from its engines, a 1.1 meganewton upwards force from its wings, that's the lift force, and a 0.5 meganewton drag force backwards, that's basically friction between the plane and the air. Draw a free body diagram of the plane. The first step is to draw a simple diagram representing the plane, like this. All the forces are given to us in the problem, so we'll just draw an arrow for each one. We have the downwards force from gravity. That's 1 million newtons. We also have the forward thrust from its jet engines. We draw that arrow a little bit longer because that one is 1.6 million newtons. Note that we draw that line longer because that force is bigger than the force of gravity. We also have the 1.1 million newton upwards force from the lift from the plane's wings, and that's only a little bit longer than the force of gravity. Finally, there's the backwards drag force. That force is 500,000 newtons. And that's it. There's our complete free body diagram of the plane.